In this tutorial, we'll take a look at working with integer exponents. And these are a whole bunch of metric prefixes that you may be familiar with. Probably more familiar with the ones near the middle. Meter, for example, kilometer. The biggest I have here is the terameter. And terameter, the capital T is the abbreviation for tera. Terameter is, now remember, this is thousands, millions, billions, so it's a trillion. In this case, meters. So a trillion is 10 to the 12. Notice there's 3, 6, 9, 12 zeros here. So that would be 10 to the power of 12. Now if we go down by a power of 3 from 12 to 9, instead of trillions, this is billions. So that's a gigameter. Giga means a billion. Mega is a million. So 6 zeros, so that's 10 to the power of 6. And maybe I'll bring my calculator over here just to demonstrate some of this. So, for example, 10 raised to the power of 6 is a million. Is that million there? Kilo, K means 1,000, so that's 10 to the power of 3. Hecto means 100, so it's 100 meters, 10 to the power of 2. Deca means 10 to the power of 1, so that would be 10 meters. And then we have the meter, of course. Now, I'm going to go in order here. Well, I skipped a few here, went 12, 9, 6, but now I'm going to go in order 3, 2, 1. Notice if I divide 10 to the power of 3 by 10, I get 10 to the power of 2. Remember, when you're dividing powers of the same base, you subtract the exponents. So let's get my pen in here now. There we go. So if you take this 10 to the power of 3, and divide it by 10, or 10 to the power of 1, remember you subtract the exponents. So 3 minus that 1 is why that's 10 squared there. And if I take this 10 to the power of 2 and divide it by 10, or 10 to the first, then this 2 minus this 1 is 10 to the power of 1. And so that's why that's 10 there. Go back to the pointer here. So if I divide 10 by 10, I get 1. And that's the same as 10 to the power of 0. See, there's a power of 1 here. And 1, well, it would be 10. Maybe I should do that one too. It would be 10 to the power of 1 divided by 10 to the power of 1. And the exponent then would be this 1 minus this 1. 1 minus 1 is 0. So that's 10 to the power of 0. So that's why that's 10 to the power of 0. Now, 10 to the power of 0 is the same as 1. Anything to the power of 0 is equal to 1, with the exception you can't raise 0 to the power of 0. What a power of 0 way you can interpret it is you actually divided something by itself, and that's another reason why you get 1. Now, if I divide this by another 10, I'm going to get 10 to the power of negative 1, because what it looks like is this. We're taking this 10 to the power of 0 divided by 10. So 0 minus 1 is negative 1. So that's why that's 10 to the power of negative 1. Now 10 to the power of negative 1, and I can bring my calculator over here, and 10 to the power of negative 1, whoops, not 0.1, negative 1, is 0.1. So that's where the 0.1 comes from. Also, see, if I take 1 and divide it by 10 instead of the power of 10, I get 0.1 as well. See, if I divide this by 10, 0.1 divided by 10, I get 0.01. And if I divide by 10 again, I get 0.001. Okay, so with the powers of 10, see, we're actually just subtracting 1 from the exponent every time you divide by power of 10. So that's why the 3 becomes 2, becomes a 1, becomes a 0, becomes a negative 1. So the next one would be 10 to the negative 2. Next one would be 10 to the negative 3. Now, notice that I want to draw a few conclusions here. Number 1, this negative 1 means there's 1 decimal place here. The negative 2, there's 2 decimal places here. The 3, there's 3 decimal places here. Okay, so this one here, notice there's 1, 2, 3. I skipped a few here. So 1, 2, 3, 4, 5, 6. Micro is not the next one, like right after milli. You would get 10 to the power of negative 6 because there's 6 decimal places here between the decimal and the 1. And this next one, there's 3, 6, 9 places, so that's actually going to be 10 to the minus 9. And then this one is 3, 6, 9, 12 places, 10 to the negative 12. And then this would be negative 15, the femtometer. Now, a couple things about integer exponents. The 0 exponent, and then where I already talked about that a little bit, why it's 1. The negative exponent 2. The negative exponent just means the reciprocal. So you see, this is here 10 to the negative 3 is actually the reciprocal of 10 to the power of 3. See, 10 to the negative 3 is this 0.01. Get my pen back here. And 10 to the power of 3 is 1,000. So what I'm saying is, because the reciprocals, then these, the 0.001 is the reciprocal of 1,000. See, if I take my calculator and divide, that's the reciprocal of 1,000, I will get the 0.001. And I can show that with my calculator. 1 divided by 1,000 gives me that 0.01. So that's what a negative exponent means. It means the reciprocal of the one with the positive exponent. So 10 to the negative 6, for example, is the reciprocal of 10 to the power of positive 6. 10 to the power of 6 is a million. 10 to the negative 6 is, this is actually 1/1,000,000th. If we take 1 and divide it by a million, I will get 0.000001. So that's a little bit about negative exponents. So let's flip over to the next page. Oh, right, I forgot my fractions in here. Let's get rid of my, there we go. So this would be a tenth. This would be 1 over 10 squared, or 1/100th. This would be 10 to the power of 1 over 10 cubed. Again, because there's 3 places here. See, 10 to the negative 3 is the reciprocal of 10 cubed. Like I said and wrote, this was the reciprocal of a million. So 10 to the negative 6 is the same as 1 over 10 to the 6. And then we'll write the last 3 as well. So 10 to the negative 15 is the same as 1 over 10 to the power of positive 15. So I talked about the 0 exponent a little bit in the previous page, but here's a more specific, concrete example. Let's say I have x to the 4th, and it doesn't matter, it's 4. The exponent here could be 11 or negative 53. It really wouldn't matter. The thing is that they're the same. So I'm going to evaluate this in 2 different ways. And one way is I'm dividing something by the same thing, so I should get 1. That's one of the rules of numbers. Divide something by itself, you should always get 1. But also, or similarly, I could divide these and instead use that power rule that I'm dividing 2 powers of the same base. The base is x, and so I can subtract the exponent. So it's going to be x to the power of this 4 minus this 4. And of course, 4 minus 4 is 0, so that's x to the power of 0. Now I evaluate the same thing, just 2 different ways, so this should equal 1. So that's my conclusion here, that x to the power of 0 equals 1, and the one restriction is that x can't be 0. The reason x can't be 0 is because I can't do this. Like, let's say the exponent was 4 again. Because 0 to the power of 4 means 0 times 0 times 0 times 0, which is 0, and in the denominator we have the same thing, and you can't divide by 0. That's actually called an indeterminate form, so this is not defined. So that's why we say that the base can't be 0. Oh, get rid of that. Okay, back to my pen again. Now the negative exponents, again, I'm going to evaluate this 2 different ways. A cubed over a to the 5th, 2 different ways. So a cubed means 3 a's multiplied. Now, not 3 a's added, 3 a's multiplied means a times a times a. There's 3 of them, that's why there's a 3 here. And the a to the 5th in the denominator means there's 5 of them multiplied. So a times a times a times a times a. And if you take any 2 a's here, let's say that one and that one, a divided by a is 1. So we can divide those out. I could divide this a out with that one. I could divide this a out with that one. Actually, when you divide these, I didn't write all these in here, but you see when I divide that a into this a, there's actually a 1 here and a 1 here. When I divide this into this, there's a 1 here and a 1 here. And the same with these. There's actually a 1 here and a 1 here. So on top, you actually have the product of a 1 and a 1 and a 1, which of course is 1. And in the denominator, we have a times a, which of course is the same as a squared. So notice what you're doing when you're dividing these powers with the same base is you're actually, to simplify it, you're actually dividing out factors that are the same, bases that are the same. Like a divided by a is a. If this is x and this is x, x divided by x is 1. I think I said a divided by a is a. A divided by a is 1. X divided by x would be a 1. If it was m divided by m, that would be 1. So notice that this 2 comes from the fact that we're actually, there's actually 2 a's left here. So that's why it's an a, because there's 3 of the a's divided with 3 of the ones in the denominator, so that's why there's 2 of them left. Now, we can also evaluate this by subtracting. The power rule says dividing with the same base. If we subtract the exponents, so 3 minus 5 would be negative 2. So I evaluate the same thing, just 2 different ways. So this and this have to be the same thing. So my conclusion is that a to the power of negative 2 is equal to 1 over a squared. And we could change the exponents here, but in general, if you have, let's say, a to the power of negative n, where a is some base and n is some power of a, and I'll say an integer exponent here, but actually this works for decimals as well. That's the same as 1 over a to the power of n. Basically, the reciprocal of this, it's 1 over a to the power of n. Notice that that's negative, but it's a positive here. So it's a reciprocal of a to the n. And again, a can't be 0. So that's how you evaluate a negative exponent, and of course a 0 exponent is always equal to 1. And we'll take a look at these through a couple of examples on the next page. Actually, these are all about negative exponents, no 0 exponents here. So if I have 4 to the power of negative 3, then that rule at the bottom of the previous page says that that's the same as 1 over 4 to the power of positive 3. It's a reciprocal of this to the positive exponent, raised to that positive power. And of course I can bring my calculator back and turn it on. 4 cubed, 4 to the power of 3 is 64. So this is equal to 1 over 64. Oftentimes you'd be asked to write this without a negative exponent, so it's 1 over 4 cubed, and then evaluate it and leave it as a fraction. So you just evaluate that denominator, and you get 64 in this case, is 4 cubed is 64. So that written as a rational number is 1 over 64. Now in B we have negative 5 raised to the power of negative 2. So the exponent that's negative means this is the reciprocal of negative 5 raised to the power of positive 2. And that means negative 5 times negative 5, which of course is 25. So negative 5 in brackets raised to the power of negative 2 is 1 over 25. Now in C here, I have almost the same thing. Notice the difference is there's no brackets. See here, that power of negative 2 was applied to the entire base. But here, because there's no brackets, that power of negative 2 is only applied to the base of 5. If you want to put brackets on this, it would actually look like this. But we don't really need to put those because the 5 is just a nice whole number. Let's get rid of those. Right, there we go. So this negative is this negative here, so we're really just doing the reciprocal of 5. Well, 5 to the negative 2. So 5 to the negative 2 is 1 over 5 squared. And so we're only squaring the 5. No, we don't have a negative 5 to square here. So 5 squared is 25, so this would be negative 1 over 25. Again, that negative is that negative is that negative, and that negative does not belong to the base of 5 that's raised to the power of negative 2. So that's the difference with having the brackets around the negative 5 or not having brackets. Notice they're exactly opposites. And I can show you in my calculator. Notice that if I put brackets around negative 5, raised to the power of negative 2. Okay, so 0.04. Now this is the same as 1 over 25, just to show you. And if I go negative 5 raised to the power of negative 2, I get the opposite. So, of course, that is the same as what we have here, negative 1 over 25. That's at negative 0.04. Now, one last example here. I've got a fraction, a rational number, to the power of a negative. I have a negative power raised to. So I'm going to show you kind of the same way as what I did up here, but I'm going to show you a shortcut to these as well, because of the fact that the negative exponent means the reciprocal. So this would mean 1 over the 2/5 raised to the power of positive 3. So what we would do next is I would take that, and this is dividing fractions. So this line here means dividing. So I've got this 1, and I'm dividing it by this rational number or fraction. So I would change the dividing into multiplying by the reciprocal. Reciprocal 2/5 is 5/2. And so what I want to do now is, now 1 times this is the same as just evaluating the 5/2 to the power of 3. I'm going to, that power of 3 means I'm going to cube the 5 on top and cube the 2 in the denominator, and I would get 125 over 8. And just to demonstrate what those look like, 5 raised to the power of 3 is the 125, 2 raised to the power of 3 is the 8 in the denominator, so that's 125 over 8. So that's kind of the standard way to do it, like up here, but I'm going to show you a different way. So if you remember this, you can do this a little bit quicker here. The negative means the reciprocal. So this is actually, excuse me, the same as 5/2, okay, reciprocal of that, raised to the power of positive 3. And so notice this is actually the same thing as we evaluated here, and so it's 125 over 8. So if you have a fraction raised to the power of a negative, it means the reciprocal, okay, so I did the reciprocal, raised to the positive power. Okay, so it will give you the same thing. So that's another way to simplify that if you have your base is actually a rational number. And that's the end of the tutorial.